Okay, so before we start, um, so last time I said that this week, so today class we will have a breakout session. So I'm actually not sure whether we have enough time for the breakout session today, because I just noticed that Sunday is a public holiday, so we will not have a class on Sunday. This is first Ramadan, right? So we will not have a class on Sunday, and the class on Sunday is basically a 3-hour class, and it's actually at the beginning of the week, and then we only have the next class on Thursday, the next Thursday. So today I basically will uh, give a brief and the briefing for design project. So I'm going to start the briefing today. Okay, so by next week, and starting from you should have your holiday on Sunday, but then you should start work on the first project for SEMO3523, which is hull form design lah. Okay, but the briefing will be done today. When supposedly, if you look at the course information, so the design project briefing should be done next week. Yeah, so we will start the first project by next week. Okay, but since Sunday is a public holiday, so I decided to give the briefing today. Okay, and then the next week, Monday, you can start with the first design task basically. Okay, so then by next class we can have at least a progress of what have you done for the first design project. Okay, right, so before that, before we proceed with the design the first design project. Okay, so this one is for SKMO students, yeah. Because last time in the first class I mentioned that because this SEMO 3523 is a bit different, yeah, the curriculum is a bit different compared with what have your friend from SKMO have go through in SKMO 3523, and the name is also different even though the code is changing from SKMO to SEMO. 3523, still the same number digit, yeah, but the curriculum or the content is different. Okay, so previously it's a ship and offshore design 1, but now it's integrated ship and offshore design 1. Yeah, and integrated ship and offshore design means that is and it's basically there is this prerequisite subject which is SEMO 3512, and that you have to pass before you can enroll to SEMO 3523. Yeah, but since you guys from SKMO, you're not taking the SEMO 3512, yeah, so there are some missing part from that 3512 or from your previous friend's curriculum. There are some missing part. So decide after we do some discussions with Dr. Xiao, who is part of the lecture for this subject, and with the director as well. So we have to give you extra assignment lah. Yeah. So if you look in the e-learning, let me just share this PDF. Where is my PDF? It's not display, right? Where is it? Ah, there it is. Okay, so if you look in the, sorry, where is, so I'm not opening the, okay. So in the e-learning, I have uploaded two tasks, yeah, two tasks for this week, basically. Yeah, so the first task is purposely for SKMO student only. Yeah, but if any SEMO want to do, by all means, you can go ahead. Yeah, but this one is only for SKMO. Yeah, for Atira, we see Amir, Irshad, you can see who else, Anas, Ashraf, correct me if I'm wrong, who else, Haikal, is it? Arif Rizki, is it Arif Rosatlan ke apa? Oh sorry, that one is Arif, it's Alif, right? Alif Rosatlan. Alif, Then I think there are some siapa Hafizi, if I'm not mistaken. Okay. And if anyone else that I miss. Okay, so this assignment is for you only, basically, right? Okay, so just let me go through for those for SKMO. Yeah, so what I have asked you last week is basically to get the mean dimension design report of your group. Yeah, so you have your design group. I hope you know, or you already know who is your group members. Okay, so get the dimension design report and get the mean dimension that I have marked previously. So I also have uploaded that mark or the report that I have marked in the e-learning. Okay, get the mean dimension design report. If there is any comment, read also the comment. Okay, and read and go through every page, yeah, from the first page, introduction and whatsoever until the last page, yeah, to make sure that you understand. Yeah, apart from last class, where I give some recap on the mean dimension procedures, yeah, you have to go through as well, yeah, because by now, after this, yeah, starting from next design task and until your IDP2 later on, so you're going to sit in same design group. Okay, so you have to know from the beginning how the process of getting the mean dimensions, yeah, what have your group members go through in SEMO3512 to finally get the mean dimension. Okay, because I cannot recap all the lectures that are given in SEMO3512. So this one is on you yourself. Yeah, so you have to put extra effort for this one. Yeah. Okay, so based on that design requirement, so last time I said that, so let's say this group, so Amir, group 10, yeah, for example, so Amir Irshad is one from SKMO. So we have Firdaus, Nabila, and Pugalanti. So basically last time, the requirement is that, for example, for group 10, what is your design requirement last time? I cannot remember. Let's say the general cargo. So 3,000 deadweight tonnage. So I say that one person will take that original requirement, which is DWT of 30,000 deadweight tonnage, and another two will taking 10% higher and 10% lower. Okay, so for Amir Irshad, you also will take the original requirements, which is 30,000 deadweight tonnage. Yeah, general cargo, 30,000 deadweight tonnage. For example, I'm not sure. Yeah, I'm not sure. You have to check back what is your design requirement. So for those from SKMO, you will do the original requirements. Yeah. Okay. So then what you have to do is that you have to repeat the same process. So you have to learn about how they get the main dimension. Then you have to repeat the same process. By all means, you can copy. Yeah. By all means, you can copy, but you have to do it by yourself. You have to do in the Excel. You have to do the manual calculation by yourself. Okay, but you always, I mean, you can refer to your friends or your your group design report lah, but you have to do, you have to repeat the same process by yourself. Do not just copy directly. Okay, uh, this is to make sure that you understand how to get the mean dimension, because this is the crucial part. Okay, but it's a tedious part where require more than 3 to 4 weeks, which you don't have in this SKMO 3523. Okay, so this one should be on your own lah. Then, okay, what you have to do, so basically this is the output from previous SEMO 3512. Your friend from SKMO also did this, yeah, where they come up with this mean dimension report. Yeah, but since this is just a extra assignment for SKMO students, so you have to write a design report. There's no like a limit, 5 ke 10 ke, but whatever it is, that design report should have all this. Yeah, should have all detail that I put in this PDF. Okay, you should have the cover page, you should have the executive summaries, table of content, all the explanation of the content was given here. So it's given here. So please read. Yeah. So you have to have these introductions, aims of the report, yeah, design requirements, yeah. But of course, you cannot directly copy, paste, yeah, from your group design report. Yeah, I can check that one later. So design requirement, that the calculation of your mean dimensions. Yeah, so the calculation of your mean dimensions, this manual, there should be also example of calculations, manual calculations. Yeah, so that manual calculation should be handwritten. The rest you can do per copy paste or whatsoever in words. Okay, but the rest for manual calculations you have to do it handwritten. Okay, so one sample calculations only. The rest of it, because you have to do the iteration process, so that one is to be included in the appendix. Right, so results discussion, conclusions, yeah, typical reports. You should have the reference and appendix, if there is any appendix. Okay, so go through this PDF as well. Right, so this is the assessment criteria. So basically in terms of the technical, in terms of your writing skills, and in terms of your literacy skills, yeah, the reference citations and so on. So this one should be the extra assignment lah for SKMO student. Okay, so I put it here, the instructions, yeah, to be submitted 9 April. Yeah, should be submitted 9 April. It's actually not to disturb the next progress starts lah, because after this you have to proceed with the hull form development. Okay, so if you are working on this main dimension, so you're not able to catch up with your the rest of your group members. Okay, so spend some times. Yeah, you can start your main dimension with whatever values that your friend already get. Yeah, and then you just do some iteration process to finally get whatever values for your requirements. Okay, so is that clear for SKMO student? Any questions? Okay, yeah. So I think most of the group, unless unless some of group yang they don't provide content that require last time, so, but most of the group submit I would say a good report lah, a comprehensive report contain all this content that I need. Yeah, so should be okay, should be enough for you to go through the design report and do your own mid dimensions calculations. Okay, right, then if all clear, so I should proceed with our next. Right, okay, clear, yeah, clear, all right. Okay, that's it for SKMO. Then, okay, this one is for the rest, yeah, for all lah, basically. So by next week, we should start with your hull form design. Yeah, so if you look here, there are several steps that you should go through from week 3 to week 7. So basically, we have 5 weeks, yeah, to complete your first report, yeah, first project basically. Okay, so for next week, basically, so you're going to start your hull form design. I have uploaded this PDF in the e-learning, so you can go through that one, this one later on lah. Okay, so that's why I said for SKMO student, you should have your main dimension ready by 9 April, so that at least you only have a buffer of 1 week. Yeah, but maybe next week your friend will already start, but you can also start. Yeah, means that because most of the group member, they have done based on the original requirement. Yeah, so you can proceed with the original requirement based on your friends from SEMO, but the extra assignment is apa tu, a side work lah, basically, to make sure that you understand how they get the main dimension. Okay, Right. All right. Okay, so there are so many apa ni um, things to start here. Okay, let me just share. You can basically read this one later on, but what I'm going to explain here is also coming from this PDF lah. Okay, but I'm going to sketch so that you will have a brief idea on the next design task. Yeah. Let me just share this one. Oops, sorry. Okay, return to meeting. Send briefing. Okay. So stop sharing this one first. Oops, where is the stop sharing? Okay. Okay. What happened? This one dia tak nak. Okay. Right, so as usual, I'm going to sketch in my iPad here. Okay. So basically, if we look at your basic ship design process, yeah, so we recap back your basic ship design process. So you start with your mission requirement. Can you see this one? Okay, mission requirement. Okay, so then that mission requirement is translated into the owner's requirement. So mission requirement is a bit different compared to owner's requirement. So mission requirement is what is the mission. Yeah, let's say if you want to transport a cargo from one port to another port. So that is basically the mission requirement. So you want to transport a container or you want to transport a car, yeah, from one port to another port, for example. So that is a mission. So the mission is to transport a vessel, a car, or to transport a liquid, or to transport a bulk cargo, or to transport livestock carrier. So that is the mission requirement. Then that mission requirement is translated into the owner's requirement. So that owner's requirement too, you are given in terms of the ship type, yeah. So which actually coming from the type of cargo, right? And then you are given the WT, yeah, the deadweight tonnage. You are given the speed, right? So that is the three owner's requirement given to you. Then from that owner's requirement, you actually come up with this design requirement. Okay, so this design requirement including the deadweight, speed, and so on, and include also the route. Yeah, so you design here where is the route, and then you design also the endurance. Okay, and whatever design requirement that from the owner's requirement you translated into the design requirement. Okay, so from that design requirement, then you go into the main dimension. So based on the owners, you translate into design requirement, and then you come out with the main dimension. Okay, so this main dimension is what L, B, D, B, D, T, C, B, yeah, that you have found based on the main dimension determination process. Okay, so basically this is actually, if you go back into the design spiral, so this is the first stage of design, which is the conceptual design. Conceptual design, right? So that is the design process, conceptual design. Okay, now once you have your mean dimension, so the next step is develop your hull form. Okay, develop your hull form. Okay, so to develop this hull form, what you need, yeah, basically, of course, you can start from scratch. Yeah, you can sketch, and then based on the sketch, you can come out with the hull form. Okay, but that will require a lot of experience. Yeah, to just sketch a ship or a vessel. Okay, in order to develop the hull form. Okay, of course, some of you have did this sketch last time. Okay, where you sketch based on a certain stern profile, yeah, the middle body profile. Okay, then you sketch the hull form. Okay, but that, like I said, it will require you a lot of experience to come up with a very good hull form design. Okay, so what we're going to do here is basically you have to get a basis ship, okay, or reference ship. Yeah, that basis ships need to have a lines plan. Yeah, lines plan and also the main dimension. Okay, so this is the input. Yeah, this is the input. Yeah, to develop the hull form, you need to have the basis shapes. Yeah, with that basis shape should have the lines plan or should have a main dimensions. Okay, so where you can get this, all these basic shapes, so you can get from books, you can get from internet, or if you have any, let's say, because some of you already, most of you I think, okay, most of you already go to your upper industrial training, maybe you can sneak out some lines plan previously. Yeah, I'm not sure that one, because yeah, maybe some company they have this big ship lines plan, so you have that copy, so doesn't matter as long as it is not going to be published ke whatsoever, so it's not apa, a privacy concerns lah. Okay, so book, internet, or wherever you can get. Yeah, there's also apa tu, a trick lah, if let's say you cannot find your basic ship. Yeah, so it's okay, there's actually a method how you can get that, how we can do that lah. Okay, so this basic ship should have a lines plan. Okay, and it should have the mean dimensions. Yeah, so mean dimensions LBDT lah. Yeah, so this LBDT, you should have the mean dimension for the basis shape as well. Okay, so you can get from hard copy, soft copy, and maybe there's apa tu, someone did this, dia panggil apa, grab cat ke whatsoever cat, and then they translated into a lines plan. Okay, then you can have it as well. Okay, doesn't matter, I will not ask you where do you get, means the reference and so on, as long as you have the lines plan, and then as long as you have the mean dimensions. Okay, if you cannot find the basic ships that a similar type of your ship, okay, so what you can do is that in some software, for example in Maxsurf, there is a library, you know, with the various kinds of hull form in that library Maxsurf. Okay, so you can get the soft copy of your vessel from there. Okay, Rhino, I'm not sure whether have a library or not, but Maxsurf, we do have this library, yeah, which contain some kinds of a hull form. Yeah, so basically you can start from there. Okay, the best is that if you can get a basic shape hull form of similar type of ship that you are designing, and the main dimension should be within plus minus 10% difference. Yeah, so but if still if you can get more than 10% pun is okay lah, as long as a similar type of ship, but it's good if you can have 10%, yeah, plus minus 10%. So if let's say from here your mean dimension is 100 meter length, yeah, so here should be plus 10% of 100 or minus 10% of 100 meter. for a similar type of shapes. Okay, right. So some of you maybe get lucky, you can get within that percentage, or maybe some of you will get a very big percentage difference of your mean dimension. So it's okay as long as you have a similar type. But the distortion process later on when you develop the half form will be a bit difficult lah, compared with those who have lesser difference in terms of the mean dimension. Okay, so that is should be the first task basically to get the basis half form, right? So by next week on on Thursday, yeah, so I have to see the basis shapes for your group. Okay, so it's okay, one basis shape for the rest of the group is okay. If you can get more than one, then that should be better lah. Okay, but one should be enough, right? Okay, so then that is develop the half form. So that is the input. Yeah, in terms of the output, so from after you develop the half form later on, so basically you will have this lines plan, a new lines plan. So this one is a basis lines plan. It's a little bit lazy, right? So now you should have your lines plan lah, your own lines plan based on your main dimension. Okay, so maybe this one just now is 120 ke, but now you have your lines plan with length of 100 meter. Okay, lines plan. Okay, and you should expect this line span is in A1 or AO. Yeah. So finally, this line span is just a line span that you draw or that you produce in ship and engineering drawing. Is it? Or is it naval architecture one? Whichever lah. Okay. So where you come up with this line span. Do you remember you? Okay, I know that for SEMO student, you draw using Rhino ke? And then you produce your line span. Or do you do it manually? No, I don't think so. Am I correct? You do it manually, right? SEMO students.
I know, doctor.
Rhino, yeah. So you don't have the experience using those apa tu? Saya pun dah tak ingat, dah lama dah tak pakai. Manual drawing in that A1, AO kertas minyak AO tu, you don't have that experience, yeah?
No.
Manual saya ingat A3 kertas kot.
Ya, pakai A3 je.
A3 je. I see. Same. Okay, same. Of drawing the lifespan, right? Means there's the standard of the box, what have to be there in the plan, the plan to whatever. Last time saya meeting pun tak berapa. Internet dekat UTM ni dia tengah tak berapa ni sangat. So now is it okay or is it still lagging? Because I can oh my god. Alright. Okay for 2 seconds, then lagging. Like this. Okay. Not sure if I change to on. Let's do this one. If this like you part. Okay, is it okay or not? Or you cannot hear me? No. Right. Sequence show. Oops. Okay. Yeah. Let me get fully okay. It right. Not any. I'm not anything, but you might. Is it? You hear? Right. Let me seconds. Usually tak ada sound. Sound ke? Right. Yeah. Let me just ke? And restart model if you want to. Guys, compare the game is still working. First, okay, how can you see or not? Still like because I oh, yeah. Yeah. Okay, okay, how to do me my lead meeting from here. Yes. Hello, hello. Kalau dekat sini, you guys hear me tak? Can you hear me? Dekat sini? Yes. So, I suppose it's a problem with UTM internet. Okay. So, tak apalah. Maybe nanti dia akan okay. But because I'm using my iPad, so I cannot show you my face. Otherwise, nanti you nampak my lubang hidung je. Right. Okay. So, we go back to where we are just now. Okay, I'm going to share my screen again. Nah, email pun tak okay, where can I see your comment and so on? Right. Give me a second. Kejap. I think I should join here juga. So that so I can see if there is any like comment ke apa ke. No, I cannot be the host of the meeting. I'm the host of the meeting. Reclaim. Okay. Terlalu banyak, terlalu banyak ni masalah sekarang. Can you see my note here? Can you see it or not? Because at the moment I cannot see. Cannot. Right. Oh. Let me just do this one. Stop sharing. Can't. So I hope you can see it by now. Yes, right? So you can see in my screen as well. Okay. And you can hear me clearly. Great. Right, so I should proceed before the problem with the internet again. All right, so now, where am I? Just now we developed the hull form. Okay, so the output is in terms of the lines plan, yeah, and of course in terms of a 3D model. Okay, because this one, your 3D model, you're going to use the same model for your stability calculations, stability assessment. Okay, so basically these two output lah. So you have lines planned and also a 3D model. Right, so that, and of course a report. Miss this one. Okay, a report lah, basically. Right, so from hull form, yeah, from the develop the hull form, once you develop the hull form, there are basically two other things that you have to come out. Yeah, basically the first one is hydrostatic calculation. Okay, so like I said previously, from this hydrostatic calculation, if you're using a MaxSurf, you can directly get your hydrostatic calculation. So funny. I'm sorry, because I'm looking at the camera and I want to look to you guys, but then I noticed that I don't open the camera. So yeah. Okay. Right, so hydrostatic calculation just now. So if using a MaxSurf, so you can get directly hydrostatic properties. Okay. But then, of course, you're going to do a manual hydrostatic calculation to verify the one that you get from a MaxSurf. So that is for hydrostatic calculation. So from hydrostatic calculations, you will get or you will produce a hydrostatic curve. Of course, hydrostatic data or hydrostatic curve. I hope you still remember last time you have this different graph, so different hydrostatic data. Yeah, so all this hydrostatic data, LCB, LCG, KB, KMT, displacement, what else? KG, what else can you get? MTCTM, yeah, moment to change stream per centimeter. What else? What else hydrostatic data that you have? TCP, GMT, yes, right? And the rest lah. So basically, if you use a MaxSurf, if you use a MaxSurf, so you can get you can key in a different you can key in a different different graph, because different graph will produce you a different hydrostatic data or hydrostatic curve, right? Okay, so that is the first outcome for hydrostatic calculations. And of course, you will have this Kn curve. Okay, I hope you still remember the Kn curve. So this Kn curve will be used for the next step, which is stability calculation and stability assessment. Okay, because you're going to calculate all these parameters for stability, GZ, GMT, and so on, and you're going to assess using or based on a standard. So maybe IMO standard ke, kalau a small vessel, we have this DNV standard, or if there's fishing vessel, we have the fishing vessel standard. Okay, but usually based for big ship, it's the IMO standard lah. Yeah, assessment using IMO. Okay, so this Kn curve and hydrostatic curve will be the input for, basically the input for, okay, for the stability calculation and assessment. Right, and another, from this develop the hull form, another output is, the second part is basically the GA, the GA design, general arrangement design. Okay, so from GA design, where you're going to produce a GA drawing. Of course, last time you have draft initial GA, okay, but now you will have a more detailed GA drawing based on your hull. Yeah, so previously it based on any hull, but now you're going to redraw your GA using your hull form, whatever kind of hull form that you're going to develop later on, and based on that, so you're going to have this GA drawing. So you're going to have the profile, so you're going to have several deck drawing, you're going to have the body plan drawing, of whatever that you put in the vessel. So that is GA design. So then after that GA, so this basically the first project, and this is also the first project, the hydrostatic calculation. This is going to be your GA design, is going to be the second project. Then assessment going to be, okay, so GA design, based on the GA design also, you actually going to do the weight estimation, weight estimation, and based on this weight estimation, you're going to calculate the LCG and KG, because in this MaxSurf here, the LCG and KG usually will be given 0. It's not calculated in MaxSurf. So basically the weight estimation will give you the LCG and KG, and this LCG and KG weight estimation is the input for a stability assessment. Because once you have the stability, for stability later on, you have to identify what number, how many tanks that you have, what kind of tank. Okay, if let's say you have 2 freshwater tank, and where is the location for that freshwater tank? Right, so you have to know the length, the LCG and the KG, from the keel and from the midship. Okay, so for stability, let's say this is your ship, so you have this tank, maybe there is a ballast tank here. Okay, so you have to determine, this is your midship, for example, so you have to determine the LCG for every tank that you have, and of course the positions and the weight for every cargo, or for every superstructure, or for every structure that you have on board your vessel. If let's say you have a crane here, right, so you should know where is the LCG of this crane and where is the KG of this crane, because it will affect your stability. Okay, so then so that is weight estimation, which you're going to do in GA, GA project lah, group 2. Ni apa, project 2. Okay, so the rest is actually, apart from that, you will have, from this stability, you will also have this powering. Okay, and from this weight estimation, you also will have this seakeeping, maneuvering, etc. Okay, but you will not going to do this in our design report, in IDP, basically. In IDP2, from GA design, here, there's also another part which is structure design. Structure design, yeah. So this structure design where you're going to come up with this midship scantling drawing. Midship scantling drawing. So this is another part lah. Okay. So all this, starting from develop the hull form until all the seakeeping, powering and so on, this stage is what we call as a, what do you think? What stage we call this? From develop the hull form, hydrostatic, until this powering, seakeeping and whatsoever. What stage or in design spiral, what is this process? Yes, it's a preliminary design stage. Preliminary design stage. Okay, detailed design is once you have done with this preliminary, then you go into contract design. Yeah, so when meaning to say from all of this, so you're going to go for a contract. Then after that contract, you will have this detail. So detailed design should have all the detail until what kind of pipe, what kind of Swiss, what kind of material for the tank and so on. So all that is in the detailed design. Yeah. So the pipeline, the systems, the electric systems, all this gambar apa, plan for electric apa semua. So that is in detailed design. Okay, so by now it should be preliminary design stage. Okay, right? Okay, so if you go back, I hope you can see the PDF on your own because I don't have the PDF in my iPad now. Okay, so I hope you can see it. There are the several stages of a hull form design. Okay, how you can start with the hull form. Okay, so the first step, like I said just now, okay, so we should done with this, some introductions, yeah, or some recap. Right, now we look into the hull form design. I have less than 1 hour, I think. Hull form design. Okay, so this hull form design. Right, so this is how you're going to proceed with your hull form design. So you have your L, B, D, T, C, B. What else did I miss? No. So L, B, D, T, C, B, right? So now with your main dimension, you should have your basis shapes. Basis shape hull form. Yeah, so basically a lines plan lah. Lines plan. Okay. So this should be your task for the rest of the week lah, until the next class on Thursday to get the basic shape hull form. Okay, so like I said just now, this lines plan, it should be, if hard copy also can, yeah, if you can get from books, ataupun like I said, if you go industrial training last time and then you get the hard copy of the lines plan, should be okay. Okay, we have, but for those who get hard copy, you have to scan the hard copy so that we can do the process later on. But tak apa, tak ada masalah. If you have the hard copy pun tak apa. Okay, if you had a hard copy, it's okay. Yeah, you can get from shipyard if you have. Yeah. Okay, and then like I said just now, you should have this main dimension, the same type, and main dimensions 10% lower or higher. So it's considerable lah. Okay, then what next is actually, yeah, I don't have the iPad here. I mean, okay. Okay, never mind. Because I think the PDF tu dia belum sampai that part lagi. Okay, so never mind. It's okay, you just listen to my explanation here, and then you can read later that one. Because basically what I explain here is also whatever that I wrote in that PDF file. Okay, so now you have the basic shape hull form. Okay, same type. 10% plus minus the size. Okay, that is the requirement for the line span. Okay, so for the line span, you should have at least the profile. Okay, you should have at least the profile. So you know the LBP, you know the D. If you can know the T also is also good lah. So this is T. Oops. Okay, and your line span should also show this shear plan to show you your B here. Okay. Then you should have your body plan lah. Whatever body plan looks like here. Right? Because after you're getting your basic shapes hull form, so the next step in producing your hull form is basically digitize. Digitize your hull. Okay, so digitize your hull, there are several methods. There are 3 possibilities for digitizing the hull form. Okay, so the first one is basically a hard copy. How can I put this? So hard copy. So if you have a hard copy, yeah, you have to print that hard copy line plan in a scale. Yeah, so preferably in A1 size drawing paper or AO. Okay, so you have to print out. I'm not sure whether you have a hard copy form, but I have to mention lah. If maybe later on you will have this hard copy form. Okay, so you have to print the drawing in A1 or in AO, yeah, with scales. Okay. Then there are some measurements should be taken lah. So that one I'll explain next week, inshallah. Okay. Then the next one is basically using a soft copy line plan. Okay, this one should be more easier. Okay. So this one you can just import directly from AutoCAD ke, from SolidWorks, Rhino, apa-apa sajalah. Yeah, whatever software that you can convert the line plan. Okay, kalau you have apa the apa ni, ya Allah, the soft copy. Okay, but the soft copy, but then you can import that pictures. Yeah, you can import that drawing and then we can convert into the DXF format. So that DXF format is basically the point lah, the offset data. So let's say this is our body plan, right? So we can import this image, yeah, in MaxSurf or in Digitize It software or in Rhino. I think in Rhino is also workable. Then we can digitize all the points in the lines here. Okay, so then we can come up with our own lines plan. So basically you convert this lines plan, okay, and then you convert into MaxSurf or into Rhino, into DXF format. Okay, or if let's say you're using a software shape database or library, which is the easiest way, you just simply select the type of shape available in that database library. Okay, and that's it. Okay, but the hull form is, the hull form is actually almost ready hull form. Okay, but then you have to do some distortion process lah to make sure that the main dimension is based on your main dimensions. Okay, so the next step is digitize it software. Digitize it software. Digitize the hull. Digitize the hull form. Okay, so from that digitized hull form, so we're going to do some distortion process and so on. Okay, which I'm going to explain in the next week. So there are some distortion process. Distortion process. So this distortion process is actually part of digitize step. Okay, because once you digitize all this data, okay, digitize means that you trace the lines, then you come up with the point for the offset data. Okay, So once you digitize, you will get this kind of, let's say this is station FP, for example. So station FP, so you will get all this data. Okay, so you get the first data, I do not know lah, maybe 2.0, this one is 1.6, this one is 1.4, this one is 0, maybe. Okay, then you trace again for the next lines, and then you do with the rest of the stations lah. Okay, so then we will have this one offset data. Okay, so then that offset table or offset data, so we're going to do a distortion process. So this distortion process, yeah, you're going to calculate the scales, alpha, beta, gamma. Okay, so which this scale will change the offset data of this basis shape that you have. So this one is form basis shape. Yeah, with this distortion process, so you're going to change the offset data from the basis shape to your own shape. Okay, so now you have a new offset data. Basically, you have a new line span. So basically, you have a new shape. Yeah, so you can produce the 3D hull form based on that new line span. So that is digitized process. And in my experience, digitized process, yeah, if you work closely on that digitized procedures, you can finish the digitized or hull form within 3 weeks. So digitize only will take 1 week, should be enough. Then the next one should be develop the hull form. So hull form development. Okay, because when you digitize this one, when you digitize the data, yeah, you don't actually digitize all data, all lines here. So you just take 3, 4, or maybe some important curve only. Okay, you don't actually take every line plan that you have, every lines in the body plan or in this shear plan or in this profile plan. You don't actually digitize all these lines plan. You just digitize numbers, several numbers of these lines, and based on this line, we do distortion process. We have a new set of offset data. Then we develop the hull form. Okay, so if you use the MaxSurf, I'm not sure for Rhino. I'm sorry because I'm not the Rhino expert, but MaxSurf, inshallah. But for MaxSurf, you can do the digitized process in the MaxSurf, and you directly can get a shape of the vessel. Okay, but it's not a smooth one. You have to do some refining process and so on to get the smooth hull form. Okay, so that is for hull form development. Of course, do not worry. This one is just an overview. Okay, what you have to do for this project. But of course, every week I'm going to guide you on how you can proceed with the digitize, with the hull form development, and so on. Okay, but let me mention again. I'm more on the MaxSurf, but if you want to use Rhino or any other software available out there, so by all means you can do it. But I'm not going to guide you on that one. Okay, I can give you a brief on the MaxSurf, but for Rhino and the rest, you have to figure out yourself, right? But I believe from my experience, from your seniors and so on, most of you can do it in Rhino by yourself, right? Okay, so from hull form development, then we can go into the line span basically. So this line span will require an AutoCAD. I believe in Rhino you can also produce the line span, but you have to key in some the title box and so on. So that one is preferably using the AutoCAD. Okay. Is that clear? Boleh?
Doctor,
Yep.
using spin question.
You, I
Us?
cannot hear you. I think, is it you or me yang lagging?
Me. I
You.
question.
You, are you in UTM?
Oh. Wait, never mind.
You can type in the chat box. I cannot hear you. You become just like me just now. It's a robot thing. Okay, so basically in the PDF, that is just basically for apa ni? For basic shapes only, and digitize. But the digitized things, I'm not sure whether you have been exposed to the digitized procedures. Is there any? Have you exposed to digitized procedures? How you can extract control points or something like that from lines plan, and then you can put it in the software. Yeah, first year. Okay. So first year you have been introduced with the digitized it. But that one is digitized it, right? Ke Maxer? Shape drawing. Okay. Right. So your task, just like I said, you start looking for the basic shape drawing. Maybe some of you already have your basic shape drawing from SEMO. Okay. But you need to make sure you have the basic shape drawing just like I said just now. So you have to get the profile, so that we can draw the stem and stern and also the midshape profile. Then you also need to have that body plan, and you need to have shear plan. So itu. So from that, from the digitized process, so basically we can get a control point. That one is what we call in MaxSurf. Okay. I think in Rhino also we call it control point, but I'm not sure. Okay, but basically from that control points, you can get a resemblance of your basic shape half form. Okay, and then from that basic shape half form, we're going to do the distortion process so that we can manipulate that control point and we can produce our own half form based on the design requirement. Okay, so that is basically the challenging task where you're going to manipulate these control points so that we can produce your half form. Okay, so I'm going to okay, right. I'm not sure whether I can share. I hope I can share this one. Okay, your group livestock could not find any detailed line span on Google, only blurry GE. Should we use? Yes. Okay, so if let's say you really cannot find that detailed line span, meaning to say it's not detailed lah, meaning line span or apa, even in books pun tak ada ya you. In Papan books tak ada, in Watson or any other books tak ada. Okay, so yes, if you cannot find it, and then you can use general calcu hal. Okay, so that is for lines plan. You have to prepare your software. I'm not sure about the Rhino, but MaxSurf now we have this. I mean, kalau Rhino you have to use crack lah. Otherwise, because yang license punya is in UTM only kan. MaxSurf, we already have this MaxSurf Bentley, so you should able to use that MaxSurf lah. Okay, that is one thing. I hope you can see my slide here. Anyone want to ask? Azim pula.
Before my I try to lifetime still can find plan can just from the
Hazim, wait Hazim. Nah, Hazim pula putus-putus. Tu saya tak tahu siapa saya yang ni ke atau Hazim yang ni.
sorry because I can hear the
Yeah, I'm not sure whether Webex problem ke apa. Hazim pun dekat UTM ke?
oh
Oh, kat kampung. Okay. Yeah, maybe Webex lah kot. Okay, tak apa. Cuba Hazim type lah. In the chat box. Okay, meanwhile give me a second. Sebab saya rasa saya still tak boleh share dekat Webex ni. Dekat saya punya slide. Apa ni using UTM punya ni. So, just let me... Ada satu lagi. I have another PDF but I don't put it in the e-learning yet. Okay. Okay, I should upload this in the e-learning later on. Kalau ambil line span dari buku papan pun boleh. Yes. Like I said, by all means, you can use the papan books. So papan book is actually from Shipyard. So that is a collections of line plan from Shipyard, yeah, from papan book. So by all means, as long as you have a clear line plan, and as long as you have the main dimension, you need to have the main dimension so that we can do the distortions to manipulate the line plan so that we can produce your own line plan. If you don't have the main dimension, so then we cannot produce the scale. Yeah. So if you cannot produce the scale, then you cannot come up with a new design formula. Right? Okay, Hazim, I hope you hear me answering your question just now. You're replying, but I cannot hear you. Okay, give me a second ya. Saya tengah nak buka PDF yang the next one. I should actually share this next week, but I think you can have a look first. You can try on your own first, basically. Okay. Right. Okay, like I said, I'm not sure whether you're going to use a MaxSurf or not. But of course, if you're using a Rhino, we can always import your Rhino into the MaxSurf. Okay, right. So I'm going to share with you later on this some notes on MaxSurf. So you can go through, you can have a try on MaxSurf. So this is introduction to MaxSurf, how we can produce. Yeah, but this one is basically from scratch. So you don't have, basically you have the main dimension. So you don't have this lines plan or basis shape. Yeah. But basically we come out our own surface or our own hull form. But of course, this is just an exercise lah. Yeah. So finally we can come out with this hull, one hull form. Okay, but this is basically just a normal hull form lah. So it's not dedicated for cargo ke, for tanker ke, for container ship ke. So it's not dedicated. It's just a simple hull lah, basically. Yeah. So this one is just a simple hull. So you can have a look for this one. Yeah. So this is one notes. And then this is the next note on lines plan digitizing. So this one is more on a software called Digitize It software. Okay, so it's a Digitize It software. So this digitized software is one way of digitizing or getting the points from lines plan here. So you have this body plan, so this one here. So this is a body plan. So this body plan is a soft copy that you get from books ke, or from apa tu? Okay, from books ke, from Google, from internet, or from hard copy, and then you scan. Okay, right? So this is a digitized software where you can upload the image and you set the scale. So once again, setting the scale should have this main dimension. So see in the red box there, you have this ULCC, LOA, LBP, and so on. Yeah, so then it means that you have to have this main dimension so that the system can calculate this the scale. Okay, then you start with the digitized data. Okay, digitize one station, then you proceed with the next station. So see when you digitize digitize the drawing. So at the beginning, then the software will give you a set of data X and Y axis at this apa tu, the circle, the red circle there. Okay, so then you will have a set of offset data. So finally, you will have something like this. Yeah, the offset data station 1 until station whatever stations lah that you have. Okay, that is one way of digitize. Is it 2016 free? Yeah, I think digitize it 2016. That is one way. Okay, of digitizing. Another way is one is directly. Oops, it's not appear yet. Kejap. Okay, ada. Okay, so this also should be given in the notes. Later I'm going to give in the e-learning. Okay, so this one is a direct hull form using MaxSurf. Okay, you should have this MaxSurf modeler. Also, of course, there are some steps here. So background, okay, check unit and so on. Okay, so I'm going to skip that one. You can go through these notes later on. Try by yourself with your lines plans. Okay, so basically for MaxSurf, same with digitized software where we input the image, we input the background image, the body plan image, the profile plan image, the shear plan image. Yeah, so basically these three image. Okay, of course, I'm planning to give apa tu, what we call demo how you can do digitize using MaxSurf. I'm planning for this next week, but you can go through first. Yeah, you can try first. Okay, then setting some reference point and so on. Okay, putting the design grid. Then if you look here, okay, so there are one we call it add marker. So basically you digitize, yeah, based on the lines plan basis shapes. So we trace again some points from the body plan. Okay, and we do all, of course we do for several stations lah. Okay, but we don't actually do for most of the stations. So that why we don't do for most stations, so that we can have not too rigid when we model the software, when we model the sheet later on. Okay, if let's say you digitize a lot of lines, so later on you will have too rigid hull form. So when we do the distortion process, so the transformation will be a bit not significant. Okay, so try maybe if let's say you have 10 station, you can get 5 or 6 station. That should be enough. Okay, but this one is just a sample. So then finally when you trace this lines plan basis shape, so you can have this once digitized control point lah basically. So from that control point, so you do the same for body plan and so on. So there is one one functions in the MaxSurf, we call it the try match. So once you have that data, when you digitize all this point here just now, Okay, so then you can directly get some a rough hull form. Okay, but this is a rough hull form. You have to do some refine and so on. Okay, so that we can you can get a more smooth hull form. Right, so then at surface and so on, this is more on the refining, blah 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 and so on, and finally you can get some a more apa tu smooth lah. You can see the smooth surface here, and of course you can get the line spline. Okay, parametric transformation is another thing. Here. So this is the smooth hull form. Okay, but this one is basically the basic shape. Yeah, so we have to do the data transformation, or what so called the distortion process. Then you key in again into the maximum, regenerate the surface again, then you can have one smooth hull form. So that is the idea of hull form development. Okay, do you have the idea? Right. So I'm not sure about Rhino. Last time I think the digitizing, no. You still have to do digitizing, whether using digitize it or whether using Maxself. Then you come out with this offset data. Then from that offset data, you do in Rhino. That was the experience from previous your seniors previously. So that's how they did last time. So you have to come up with the offset data first, and then from that offset data, you draw in Rhino. Okay, so either way, either using Maxself or using Rhino. That is for digitize it. Baru digitize ya. So for data transformation, I think nantilah later I'm going to brief on that one. Because there are too many things. Yes. I mean both ya. Process digitize kena masuk report, of course. Yang itu later on lah. I mean the content of the report, of course, part of it is digitizing process. Okay. Trace the offset from a basic shape line span. Yes, that is what we call as a digitize. Then you adjust. It's not that you adjust by just adjusting to your own dimension. The process is what we call as distortion process. Yeah, Shafi'i? So it's called distortion process. So distortion process, you have to calculate, you have to come up with a scale. So you have the offset data from the digitized procedure. Then from that digitized procedure, you're going to have the scale. Okay, from the scales for body plan, half breadth, and shear plan, and so on. Then from that, you're going to convert lah. You're going to convert whatever data that you have from basic shape to your own shape. So basically, for those who going to use or who planning to use Rhino, you have to digitize. I'm not sure whether this is the correct method or not. You have to digitize, you have to get the offset, you have to do the transformation process first. I mean, you have to do the distortion process first before you can start key in all that offset data in the Rhino. Yes, that is for Rhino. Okay, kalau Maxself, digitize, produce the hull form, then do the distortion process, or stability assessment nantilah. Then do the distortion process. So nanti dia akan just copy paste saja the offset data tu dalam distortion dalam Maxself. That is for Maxself lah. So saya tak pasti how you going to do that, yeah. Right, so this week, maksudnya from today until next Thursday. So basically what you need to do is to come up with your basic shapes and to have at least try on the digitized procedures. Okay, you have to come up with the offset data and so on. Okay, so by next week, by the week of 4, will be going to have this distortion process, meaning to say transformation lah. Okay. So any questions? So I'm going to share the notes, all the notes in the e-learning. Kalau ada soft copy, kena print PDF. Soft copy lines plan. Oh, no. You do not have to print that PDF, actually. Either kalau you use a digitize it, you can just insert the image. The same goes to Maxsurf. You can just insert the image in the Maxsurf. But you have to, dia panggil apa, crop lah. You crop 3 image, body plan, profile plan, and shape plan. If using Maxsurf, yeah. Kalau if using digitize it, you just need to have that body plan. Kalau dalam in the notes, you can only have the body plan. If you have the lines in CAT version, you can actually just this is for Maxsurf lah. I'm not sure about Rhino, but for Maxsurf, you can input that directly in the Maxsurf. Or the CAT version is on what format? Is it DXF ke? DXF lah kan? Correct. Is it supposedly in DXF? Or what is the format of the CAT version? Is it CAD? CAD. But in Maxsurf, there is one module called it Maxsurf fitting. So Maxsurf fitting, you can directly put all the DXF points in the Maxsurf and then generate. And then, okay, in Rhino, dia boleh extrude or something like that. Betul? I'm not sure about Rhino. I'm not an expert in Rhino. You open in Rhino and then what actually the format? Is it apa? CAD ke? DXF ke apa? DWG. Okay, still doesn't give you DXF lah. Dia kalau macam tu, you can dia either you can apa tu? Dia ada 2 ways lah. Satu is that you print out. Dapat lines plan ya. Then from that lines plan, how are you going to develop the 3D from Rhino? Is it doable kalau pakai Rhino? I mean, if Maxsurf, you cannot directly put drawing. You still have to get the control points. The one that I showed just now yang ada star tu, that control point, so that Maxsurf can generate the 3D hull forms. But Rhino, I'm not sure. Okay, so like this, and then when you open in Rhino, so you can get directly the 3D ke macam mana? There's some control point there. Can you get the points there? I mean, the offset lah, the offset data. Can you get it? The good thing is actually if you have the offset data. But there's no way you can get the offset data. Line span should be okay. But, okay. That at the right side there, size, position, Am I correct to say the position? Apa? For every point there.
Dia position for this curve.
Position for that curve.
So if I select more like a combination of curves, dia akan bagi yang semua tu lah.
I see, but then how are you going to develop the 3D form from here?
Kalau nak develop 3D kena pakai mesh lah. Kena adjust dia punya tempat according to the water line, station and patok line tu. Lepas tu baru boleh guna yang meshing lah.
I see.
Kalau yang method ni dalam ship drawing tu kot. Ship drawing kita buat macam ni lah. So kita dapat line plan ni, lepas tu guna yang ni mesh dia jadi surface lah.
And then how you come out with the offset data?
Kalau ini dia tak ada offset data lah. So sebelum ni kalau dalam ship drawing kita buat ukur offset data daripada NTC punya model. Lepas tu
then you produce macam tu.
lukis line plan ni.
Okay. So that is the problem actually, because the output not only the lines plan, but lines plan, if you remember, you draw the lines plan tu at the bottom of the plan tu you have one offset data kan, offset table. Am I correct? Last time? Right. So we need to have that offset table, because if you remember my explanation just now, because after you develop the hull form, you have to calculate the hydrostatic properties, right? So to calculate that hydrostatic properties too, we need to have that offset data. So from here, of course, you can develop the 3D hull form, just like you said just now. So using mesh and whatsoever, so you can develop the hull form. But still, you need to do the digitized procedure so that you can get the offset table.
Also, dari sini saya buat offset table lah, ukur.
Yes. So dari sini directly pun boleh ni. I mean, boleh ukur kan, dia ada measure tools tu kan. So you select several points macam, okay, they usually we use the body plan tu. Yang lain tu kita pakai ambil the stern profile saja, yang bahagian depan tu, yang bulbous bow. So we start with this lines plan untuk digitize, but you don't take, kalau tengok sini too many lines kan, your lines plan ni for body plan. Can go focus on the body plan saja. Okay. So dia ada sampai 20 station, 21 kot, more than 20. Inilah, ni 11, 19.5 and so on, right? So usually we take maybe left side tu, mungkin you ambil a significant curve. Contohnya, the station 2, station 1, station 3, station 4, station 5, station 6. And station 7, kalau tengok station 8, 9 tu almost the same. Am I correct? So station 7, station 8 you can skip. So maybe you take station 9. So something like that. Okay, so you have to decide which lines which lines you have to take for the digitized procedure. So same with station 10. So station 10 okay, because it's the end of the station too for the midship. Then you can take station maybe 12, 13, 14 is not significant. So 15, so maybe you can take only one within 12, 14 too. So maybe you can take station 13, station 15, 17, 18 is a bit significant, I think. 18, 19 and the rest lah. So just like that. So don't take too many lines. Otherwise the digitized procedure will be so difficult because you have to digitize so many points. You have to get so many points. So kalau if you use Rhino, measure for every station, put in Excel, you have to do line by line lah. Tu dia ada water line tu kan. Water line, how many water line do you have ni? This waterline pun is too many waterline. Ada 12 waterline. Right? More than 12. 13. So this is also too many. So you have to find a significant waterline only. So cari point, digitize a point at certain station and at certain waterline only. Right? Go.
Yang MaxSurf dia guna offset data point.
MaxSurf, dia sama jugalah. But basically dia terus, dia panggil apa? Dia terus detect.
Oh.
Dia directly detect the point. Then you just copy from MaxSurf tu, you put in Excel. Kalau here mungkin you have to key in one by one lah.
Kena
You
measure.
measure satu. You measure satu, then you key in Excel. You measure satu, you key in Excel. Am I correct? Right? So either you use digitize it ataupun you use MaxSurf lah. But for 3D hull form, yes, you can use directly from lines plan too. Okay. Yeah. Dia DWG tu, as far as I know, you can, if you have DXF or I cannot remember satu lagi units. If you have that format, then directly you can get one set of offset data. Okay, for MaxSurf, you don't have to, I mean, you can have a look first, try first. InsyaAllah next week, I'm going to demo lah a little bit how you can proceed with the digitize. Yeah, insyaAllah by next week. Okay. Right. Okay, I think that should be enough for the rest of the week. It should keep you busy trying with the MaxSurf and so on. Okay, so any questions? Yes. Yep. Siapa tu? Daniel.
We use Max.
Once again, lagging.
Okay.
Lagging. Daniel pula lagging pula ni. Semua dekat UTM ke apa ni? Anyone else? Yeah, Go tak lagging. Where are you Go? At home ke? At UTM?
Saya rasa guna PC punya orang lag ah.
You use apa?
Saya ada restart tadi.
So basically Webex dekat ni lah, desktop lah kot.
Saya pun PC, tapi tadi saya ada keluar masuk sebab saya tak boleh nampak share screen.
I see. So I think Webex problem lah ni. Demo is general demo or fully guided demo? Last time I did a fully guided demo because I am so frustrated with your seniors that I give you a general demo but then you cannot follow. So then I fully guided them last time until they get a smooth apa ni. So but that time it takes me 3 weeks kot. To finally realize that you need to have a fully guided demo. So your seniors, they wasted about 3 weeks last time. They do not know how to do and they don't ask me. Then, okay. Right. So of course, it's not a fully guided until you get because the digitizing process too, you have to explore first. Okay, so that's why I'm going to give you the notes so then you can try. Okay, try first the digitized process because the digitized process will take times, yeah, because you're going to digitize several lines, not only 1, 2 lines. So that digitized process will take a bit time. So please explore first. Okay, by next week, if you have any questions, so by then I should know whether I will have a general demo saja or a fully guided demo. Last time we used MaxSurf to get hydrostatic and curve, but the procedure is we draw the top side, then get the stability. So for stability of shape, basically we need to draw shape or just get the point from digitize, then transfer to MaxSurf. For stability of shape, you draw the top side, then you get the stability. Or you draw the top side model, and then you get the stability curve, right? Last time. For stability of shape, you have to draw the shape. Yes. So same, you have to draw, last time you draw the top side. So now you have to draw the shape. Okay, of course, getting the point from digitize it is not only to draw the shape. Okay, one is to draw the shape, then to come out with the hydrostatic particulars. Yeah, from that hydrostatic particulars is that you get all these KMT, KB, and so on that you have you need that properties to do the stability assessment. Okay, last time if you use that, you draw the top side, then you just get the stability KN curve that tu masuk saja. Okay, but now you draw the shape. Basically, the point tu is not only to draw the shape, but because you have to come up with the properties, and you need to come up with the lunge plan. Where in the lunge plan drawing, you should have this point ataupun this offset data. So that is the purpose of getting the point from digitize it. Okay, so you get the point from digitize it. You can have the shape hull form. You can have the hydrostatic properties. You can have the offset data. But then for the stability part, you still need to put the shape, the 3D hull form. In the maximum stability, then you have to key in all the load case lah, the loading conditions if you remember. Apa tu, fully loaded ke, half loaded ke, arrival in port, arrival to port ke apa ke, whatsoever loading lah. Okay, so that is basically for stability. Okay, so that part for stability, I believe Dr. Xiao will explain more. But by now, you should have both the shape and also the offset data from digitized procedure. Okay, transfer to MaxSurf from digitize it, transfer to MaxSurf is not the only way to come out with the shape, to produce the shape. Even you transfer to MaxSurf, you don't get a very smooth shape. So you have to do some refining. So finally, you can get a very good lunge plan. Okay, Daniel. Okay, yes, go. So this week task is to find a lunge plan and digitize the offset table. So by next class, if you have any problem with digitizing the offset table is digitizing the offset. Digitizing the lunge plan is actually to come up with the offset data, offset table. Offset data is in full scale. Yes. It's actually when you come up with the digitized tu, nanti dia akan in full scale lah, in meter. But that dia whatever lah. Kalau unit you put, basically kalau MaxSurf tu we put in meter lah. Kalau we digitize apa tu, meter lah. Kalau apa tadi, digitize it tu pun sama juga, you have to set the units. You have to set the units too. Basically that one is on meter scale dia. Apa tadi? Yeah, that one lah. Okay, so any other questions? Any other questions? Oops, tak ada questions? Okay. So I hope you clear and try at least. You have to try, otherwise, because once again, everyone needs to come up with your own half form. You cannot one person do from start, from digitize until, of course, you can do it together, yeah, just to check. But maybe like I said in Go case just now, maybe one of you take from so many lines in the body plan just now, there are about 20 station. Maybe one of you take 10 station only. And the next person maybe takes 12, maybe takes 17. It's up to you. Because the way you do the digitize will actually influence your half form later. Okay, so if too many, then your half form, your basis half form that you're going to develop later on will be too rigid that you cannot transform it. If it too little, yeah, the digitizing process is too little, means that you only take from 20 station just now, you only take maybe 5 station, for example. Yeah, so then it will be too loose. Yeah, it will not give you a correct shape of the lines plans, of the basis shape lines plan. So try to get a station that can give you a 1-for-1 Simpson multiplier. Okay, because later on you have to calculate the the hydrostatic properties. If you remember the hydrostatic properties, you have to use a Simpson multiplier of 1-for-1 or 1331, right? So try to, when you do digitize process, try to get maybe 1-for-1 rules. Okay, so 1-for-1. So maybe you can have 10 station, or maybe you can have a 15 station where you can apply this 1-for-1 in your calculation later on. Okay, so you have to somehow plan lah for that one as well. Right, any questions? Any last question maybe? It's already 12:45. Nope. Okay. So if you look later on in the PDF, it says there is a week 3 to week 7 instruction. Yeah. And we have 5 weeks, about 5 weeks, yeah, for your half form. So, but please, yeah, the half form is not only half form. So you still have to draw this lines plan in AutoCAD. And if you're not familiar in AutoCAD, maybe it takes you 1 week or 2 weeks, hopefully 1 week only. And then you have to do this hydrostatic calculation. So another 2 weeks. So basically you have only 3 weeks to spend in the half form development using MaxSurf or Rhino. Okay. And the last week should be in terms of the project report preparation as well lah. Okay, so you have to manage your time wisely. 3 weeks only for half form deployment. So by 1 week should be in terms of a design, digitize only. Another weeks in half form and another weeks is basically in refining your half form. So 3 weeks. That is the plan actually. Okay, so please work together so that you can finally get a good half form. Like I said, it's a 3 or 4 half form, yeah. Okay, so no last question, I guess. Then this should be your attendance for today. Can you see that one? So can you see it or not? I don't think you can see. I see you can see it. Okay. Too many overlapping windows. What is this? Okay, so I think that's about it, and I'll see you guys on Thursday next week, inshallah. So thank you very much, and I hope you spend some week with the design task. Right, so thank you. Right, okay. Assalamualaikum and have a good day. How many of you? Yes, selamat berpuasa for Muslim. Selamat berpuasa. Hope you have a blessed Ramadan this year. Where? How many of you? 50, 20. Okay. So thank you very much.
Doctor,
Yes. Who's speaking?
is considered a part of
I cannot hear you clearly. Can type in. What is it? Yes, this is part of project one. Of course, this is a project one. You already start with the project one. We have done with the main dimension, so don't bother about main dimension. So now you start with the project one. 37. Okay, very good. All right, thank you. And thank you, the rest of you. I'm waiting another 1 minute if there is anyone left to scan. Yes, if cannot find 10% should be okay. I say 10% should be lucky enough. I mean, you are lucky lah if you can find 10% plus or minus. If you cannot find, it's okay. As long as you have the same, ni lah. It can be done. It still can be done. Don't worry. Right, so I think that's about it. Only 27. Okay, so thank you very much, everyone. Still here. Right, Assalamualaikum and have a good day.